Hi, I welcome you all for this lecture series on analog electronics. This is Dr.G.Arthy, working as Assistant Professor in SNS College of Engineering, Coimbatore. Now, in today's session, we are going to discuss about diodes, the basics of diodes. What is a diode? Why we are using this, and how the a basic diode works. So, diodes in everyday life. Are we using diodes in our day-to-day life? Let me ask you a question. The input supply what we are receiving from the power station is, if it is single phase, 230 volt AC, 50 hertz. When you see the mobile charger, it requires only 3.3 volt DC. So the input is 230 volt, but my charger, my mobile phone require only 3.3 volt. How this is being converted? How to convert this? So let us discuss about this. So this is a diode, the symbol of diode, and practically how a diode looks physically. It is a semiconductor device and it allows the flow of current only in one direction. That is the main point of diode. Yes. Now look into this. Can you identify what is this? A mobile charger, an adapter. So you see, in the previous slide I've shown how a diode looks like physically. Can you identify any diodes here? Here we can see diodes. Here we can see diodes. Right? Here is one, here is one. So, a mobile charger, this is how a diode is inbuilt in it. So, why do we have this diode? So, every one of us is using diodes in our day-to-day life. What are the other applications of diodes? The most prominent is rectification. It is used as rectifiers. Other than that, it is used as voltage multipliers, clippers, clampers, and in protection circuits it has been used, in logic gates it has been used, and light emissions in the form of light emitting diodes it has been used, for light detection it has been used, in AM envelope detector it is used, and frequency mixer. These are few applications I've mentioned here. And what are the different types of diodes? These are the different types of diodes available in a market. For a quick review, we have light emitting diodes, we have Zener diodes, tunnel diodes, varactor diodes, pin diodes, laser diodes. N number of diodes are available. Each and every diode has its own properties, own functionalities. Now coming to the assessment part. This is the assessment. Can you name the device which converts AC to DC? And how will you identify the terminals of a diode? So if you see here, in this diode, this ring is known as the negative terminal and the other end is known as the positive terminal. This is how we'll be identifying a diode. So now what is a diode? Let us quickly have a video. This is a diode which has a body as well as a terminal stripe which represent the negative, and two leads are there. And this lead is known as anode and this lead is known as the cathode. These are few other examples, Zener diodes and light emitting diodes, which has its own functions. Now see, the diode allows current to flow only in one direction and not in the opposite direction. So it acts as a switch. Let us consider it as a switch. Yes, it flows only in one direction, and suppose if it tries to flow in the opposite direction, the switch will close. So no flow of current will be there in the opposite direction. So see here, it is allowed only in the, so it acts as a switch. And this is an example how it is being connected. So if it is connected to a battery to an LED, it flows in one direction. Conventional current direction always will be from positive to negative. Electron flow will be from the higher potential to the lower potential. So these two directions will be different. So that is what's shown here. Now see, this is one application how a diode is being connected to an LED through a battery. So this is a controlled circuit which flows in only one direction. If this is reversed, no flow will be there in the opposite direction. Here the diode is reversed. So to act as a conductor, this diode will be giving it to a positive terminal and a negative terminal. Negative should be given to negative and positive should be given to positive, which is known as forward bias. The opposite is reverse bias, which do not allow the flow of current. Only during the forward bias, current flow will be there. So see here, a forward bias circuit has been produced in order to allow the flow of current. These are different cases when it is being allowed to a rectifier, when it is being used inside other forms. So how it looks like, different applications where diode is being used as shown here. So this is when it comes from a transformer. So it acts as a rectifier. You can see the input which is sine wave and the output which is a rectified. This is half wave rectifier. So we have only positive half cycles converted. And when it comes to a full wave rectifier, we'll be using 4 diodes for a full wave rectifier. It is also known as a bridge rectifier, where both the positive as well as the negative half cycles has been converted to output. So the efficiency of this will be very high when compared to that of a half wave rectifier. So this is all about diodes. So we have discussed how it looks like, how the diode is physically represented, how the diode symbol will be, how it works, which is the major application of diode. So we are all using diodes in our day-to-day life. Maybe unknowingly, we do not know, always we are carrying it with us, and it acts as a switch which is unidirectional. Whenever the switch is open, the flow will be there, and whenever it is closed, no flow will be there. That is what we are saying is, when it is forward bias, flow of electrons will be there, and when it is reverse bias, no flow of electrons will be there. So this is all about the basics of diode. Hope you have enjoyed this session, and thank you.